Thanks for joining me for this brief presentation on the optimization of lubricin expression in 3D bioprinting using primary human chondrocytes. So, the kind of goal or the main focus of this work was to see if we could actually stimulate lubricin expression with the Bioinks in a 3D bioprinted construct. So we took two commonly used Bioinks, gelatin methacrylate and oxidized methacrylated alginate, and we combine them to find out what would be the optimal combination of them. The advantage of the oxidized methacrylated alginate is that not only can it be forward cross-linked, but it also has this tunable degradation. What we did was to use human chondrocyte lubricin promoter-driven Gaussian luciferase cells. You can see more about those on poster 603. And what we did was to use those as our kind of phenotypic output. We cultured those cells within the Bioinks in a design of experiment optimized set of conditions. What we did was to look at different concentrations of GELMA, OMA, and different cross-linking times. And here we can just see basically the winner of them all. The 12% GELMA was the only one that really kicked up the lubricin expression, here shown in the promoter-driven Gaussian luciferase. And you can see that as we increase the amount of OMA, we get increased amount of the lubricin expression. When we took those optimized conditions and then when we took the best conditions from that, which was the 12%, and we thought, well, what if we increase it up to 14%? And what if we increase the OMA concentration up to 4%? So that's here denoted by 12 and 2 or 12 and 4 with the different cross-linking times. And we can see that all of these are actually higher than our cell aggregates, which was our previous kind of gold standard. Just looking here at the 12 and 14% at different cross-linking times, you can see there's a significant increase in both cases. At the 14% with more OMA, only at the shorter cross-linking times we see a significant increase. So then we took those forward into our bioprinting conditions. We took the kind of the optimal single solution, which was the 14% GELMA, and we went up to 16% GELMA to see if that was any better. We also included the 14% GELMA, 2% OMA as our kind of optimal condition from our screen. And what we did was to kind of bioprint that into a 8mm disc, and then both at the beginning and at the end of culture we attached that disc to a slide, and we did a lap shear mechanical testing to see what the friction was between that glass slide. So looking at the lubricin expression, we can see that the 16% on its own actually increased the lubricin expression over both the 14% GELMA and 2% OMA and the 14% GELMA. However, what we did see was that the 14% GELMA and the 16% GELMA had a significant contraction. So like the cells are remodeling that gel much more than they are when there's the 2% OMA there. So that's again, kind of reinforcing that controllable degradation. Looking at the coefficient of friction, we can see that, with the 14% GELMA, we couldn't actually test the construct at day 22 because it contracted too much. But in the 14% GELMA, 2% OMA, and the 14% GELMA, and the 16% GELMA, we can see that there was a significant decrease in the coefficient of friction, really kind of supporting that we're getting more lubricin expression as we've gone through the culture. You can also see that there's a significant difference between the combination and the 16% GELMA on its own. Looking at the biochemistry of these, in all three constructs at day 0, we have pretty much the same amount of DNA, but you can see there's actually been an increase in the amount of DNA, particularly in the combination. And, making sure that we've got that chondrogenic phenotype, we can see that it's much greater in the combination than it is in the 16% GELMA on its own. And the same is true in terms of the GAG DNA. when we look at kind of the lubricin concentration, that's lubricin excreted secreted into the media, we can see that there's a significant increase between day 1 and day 10. And day 22 is about the same, but we've got a decrease in that 16% gel condition. This is somewhat reflected in the lubricin staining here, with an increased amount of lubricin staining in the 16% gel. In the type 2 collagen, just to kind of reinforce that these are articular chondrocytes, you can see that in the combination we've got much more diffuse type 2 collagen staining than here, where it seems much more surrounding the cell. Any questions on this? Please feel free to find me at the ORS or contact me by email or over Twitter.